Hello, everyone, and welcome to the Ask the Expert webinar, implementing a digital twin for the Monopoly board game using SAS Viya. My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenter, Gerhard Swolba. He is an analytic solutions architect and data scientist based in Austria. He is involved in numerous analytical and data science projects in different business and research domains, including demand forecasting, analytical CRM, risk modeling, fraud prediction, and production quality. Let's turn things over to our presenter so we can get started. Gerhard, please take it away.
Thank you very much, Tiago. It's a very big pleasure to be back again in an Ask the Expert session. And today I'm talking about one of my most favorite topics, namely programming in SAS and programming a digital twin for the Monopoly board game. What you're going to see today, I will do a very brief overview of digital twins in SAS and give an overview what this means. And then we jump directly into an example implementation of the Monopoly board game. An example implementation, what does this mean? We will speak about data step, loops, random numbers, arrays, formats, of also Visual Analytics. You will see nice reports and how you can create that. And then I will also give an outlook and some closing. That's my plan for today. Digital twins and the SAS Viya platform, this is really a relationship of two very good friends because the Viya platform is great to build digital twins, not only for the Monopoly board game. And what is a digital twin? Digital twin is also very often defined as a virtual representation of real-world entities or real-world processes. So for the Monopoly board game, we would rather think of it as a process, which is synchronized at a specific frequency. And digital twins can be used to use real-time or historical data to create simulations, create predictions, give you insights of what's happening and what's the outcome. In the graph below, you see in the middle what is a digital twin, and there are two major types of digital twins. On the one hand side, on the right, it can be a digital twin of the future. So something which allows you to predict something, create a future picture which might happen if you do the following things, where the data flows back. In our example, we are going to take a look. On what does it mean to build a digital twin of today. And with of today, I mean how can we build the digital twin for the Monopoly board game, which you see on the left, taking a look at it. So let's jump directly into that. And the Monopoly board game is a very good demo example for digital twins. Why is this the case? Because it mirrors many features which we usually also see in our practical world. It is complex, so it has a set of complex rules. You should do that, you're not allowed to do this, you have to go there. It also has a framework of opportunities and events, so which is the board where you circle around. You have some additional instructions, external things are happening, which we also see in business practice quite often. It has a random component, also very well known in many business situations that we have. It has a monetary dimension, that's also the case. And some versions of the Monopoly board game, not the one we're looking at here, but some versions do have, there's also a dynamic component with a third dice. So this is why this is a very good example for the Monopoly board game. I would take a look together with you on 3 example business questions that we could ask us now. So we could, for example, say, yes, we have a dice. It's all random. The dice is random. Consequently, if we use the dice to circle around the board, all fields will be visited with roughly equal frequency. This could be question number 1. Question number 2, we always are intended to buy the expensive properties. So is it really the higher the price, the better, just buy that one? Or is there more to consider? And last but not least, I experienced that, my grandmother experienced that. Why do the children win more often than I do? This is a question which we'll answer at the very end of our webinar today. In order to answer these questions, we could now play Monopoly 1,000 times. We could document the positions of the playing token, and we could record the profit and loss account for each card, for each player by hand. And you will agree, yes, it's technical, it's theoretical possible, but nobody wants to do this. Or we can program a digital twin. And programming a digital twin is something which we are going to do right now. And I have split my presentation here into smaller pieces where we slowly work from a simple example into more complex example, considering more rules, take a look into visual analytics, and walk slowly into a more integrated solution. What you're going to see here is also content which will in the next days be pushed into a series of SAS communities articles published by me. And I'm happy to have you there as an audience as well, where you can read the code, have more explanations and have more insights, and also can try this out on your own. Let's get started with the first business question. Is the is the visit frequency of the fields of the Monopoly board games roughly equally distributed? So if we think of this, yes, there's the sum of two dice, but there's also the go to jail directive, which changes a little bit. There are also event fields which tell us go here, go there. And as I said, for some versions, there's also this accelerator dice. So let's take a look and find out how can we implement this, how can we build this. And we start with a very simple first example being built in SAS data set. So what does this mean? What is the big picture of what we will be doing here? We will create data step loops, and data step loops is a very powerful thing. We will create a data set where we use two loops. So we loop over games, we loop over rounds, we loop over players, so to get our simulations rolling. And then we have certain actions. For example, we roll the dice, we follow certain instructions, and then we output the record. That's the basic example, but we will now go into live code and live coding examples to get a deeper look what this means and how this looks like. Let's start with our demonstration and video number one. So I will jump back and forth now between slides and the videos. And what you see here, I created a SAS program where I set some macro parameters. For example, I want to create 1,000 games, each game with 100 rounds. And I have, as we have said, a data step. I create a fresh data. I created an array for my players. And here I have a do-loop game from 1 to the number of games. And for each game, when we restart the game, I need to initialize it. Round is 0. Each player starts on position number 1. And then we go and add the rounds to it. So we loop over the rounds. For each round, we also loop over the players. So I just do the do loops. And now we need to insert here instructions by saying, okay, what happens? We roll dice number 1, we roll dice number 2. We sum up the dice to have the number how much we move forward. So you see here I use SAS functions, random number functions, and sum it up. And then we move forward the position of each individual player, which I use from the array, with the dice sum, which might happen that it has 40 fields. I overrun place number 40, so I use the modular function to push this back again on values between 1 and 40, and then I output the record. So let's run this one. So you see, running this for 1,000 simulations, 100 rounds per simulation, this goes very quickly. SAS. We now do an additional data step where we only keep the last record of each round, because for each round we have documented for player 1, for player 2, for player 3, but we only need the last record because here we have the positions. So we use the last statement in a SAS data step to keep the last entry. And now we have quite a nice table. We have for each game, for each round, the position where the player is sitting. However, we have it in columns next to each other. So we need to use proc transpose to transpose this data set by game and round to get the repetitions of player into the records. So we created from a wide structure into a long structure, which we see here. And finally, we just do some additional renaming and adding the scenario name that we had and some additional data to it, to this data set. And now we plot it with proc sgplot. What's the frequency distribution? What's the histogram for it? And not a big surprise, that's quite even. We were just circling around the Monopoly board game. That's quite simple. We see slightly a little bit of a up and down at field number 8 and 7, which we will explain in a second why this is the case. Let's now go and rerun our simulation, but don't play 100 rounds, but only play 10 rounds. So what would happen if you only played very short games? And if we run that one, we see if we only played very short games, we see the fact that all players start on place number 1. The visit frequency on the next fields is quite high, and we know that the sum of 2 dice is a triangle distributed. This is why we saw this, this step up and this step down. So this is what we had here. And now we go and enhance our code a little bit. We enhance our code. We said, yes, we follow the instructions that we have, but with many Monopoly versions, it's also the fact, if you roll a doublet, so dice 1 and dice 2 show the same numbers, you are allowed to roll again. And with this code, if they are equal, I'm allowed to roll again. This is what I do here. So I increase the dice sum again and again as long as I roll a dice. So you see this, I rolled my first dice, I rolled my second dice, and I sum this up, and the rest of the code stays the same. So you see how easy it is just to add additional scenarios, additional versions, and we run this again, and we will see, very shortly that, of course, the output will not change. It's almost the same because we didn't. It's again still quite evenly distributed. So this was a quick jump into the first very simple example that I wanted to show you how easy it is to create 2 loops over this scenario. You can say, okay, so far nothing special happened because we were just doing running this over the rounds, no special conditions added. So let's get a little bit more specific. So let's go and consider the go to jail directive. We know there is on field number 31, there is the directive, if you land there, you need to jump to a different, to place number 11, which brings you to jail. And if you are in jail, you need to stay in jail for 3 rounds. This is one of the rules which is frequently played. So let's first see how can we implement that and what are the consequences on our distribution. So let's dive into and take a look how this looks like. Running our code again and having the starting a video, we see I now add a macro parameter here which says consider jail yes, because with this macro parameter I can then easily control my program or use it in a macro. And we will see here that I have now this macro condition if I could go and consider this, because maybe I would like to try out a scenario where I do not consider jail, but if we consider jail, we have the question, if I land on 31, it relocates me to place 11. So this is what this short statement shows you. If the player positions 31, relocate to position 11, and also initialize the counter for Gerhard. He just landed in jail, so he needs to wait there for 3 rounds. And with each round, when I come again, and it checks, oh, Gerhard is in jail, he's not allowed to move forward, I am just moving here in line number 68. You will see it in a second. I'm not moving forward, but my counter is decreased by -1, which reduces the number of times I move it. Let's take a look. What is the consequences if we look at this now in the histogram, run the entire code again, and we immediately see what this means. We have now a different histogram. Of course, 31 has no visit frequency because everyone is sent away. He's sent to field number 11. And not only field number 11 is high now, but also the fields after field 11 are a little bit higher because you start from there more often compared to from other fields, which also has an influence on the visit frequency. This is something which we can see and we can take a look at. So after implementing our first very simple rule, go to jail, if you're on 31, move to 11, we see the results not only changing for 31 and 11, but also consequently for the consecutive fields after jail, because you start from there more often, and we see this slight bump here in the chart on fields 12 to 21. You also see that I have started creating this into a visual analytics dashboard because I'm a big fan of running analysis in SAS in a data step with procedures and visualize them in SAS Visual Analytics, because the fact that these tools are so close to each other allows you to do very fancy things and create nice dashboards for your analytics consumers. Let's take a look how this looks like, what I needed to do, and dive a little bit deeper into that. So we jump into chapter number 2, and I'm going to explain you how you can create a dashboard in SAS Visual Analytics. The first thing that I did here is, and you see it in the video right away, I was creating an empty table as a repository, which would bring me my where I store my scenarios. So I'm just creating an empty data set, my Monopoly visit scenario repository, and I have here a macro which just uses proc-cas util, where I load this data set into CAS, into my CAS user library, and saves it there, so I can use it then in Visual Analytics. So this is also a table, SAS table, which is accessible in SAS Visual Analytics. Now everything stays the same. I run my scenarios like I did earlier. The only thing that changed is I have an additional code at the end where I say into this Monopoly visit scenarios data set, I append equals yes, the worker player location data set. So the outcome from our previous analysis, which we did, we just appended to this data set. So this is something where the same thing runs, and you see it's already almost ready here in our data set. But let's now jump into how this looks like when this scenario is here and what we can do from that. So you see our first scenario, which we called basic game, will come up here very shortly, and we see that the code that we just ran was the same. Yeah, so I'm repeating here a little bit in the video what I did earlier. It's running, and we see that this is now pushed into SAS Visual Analytics. So let's give it a second. It's now appending the data, and the results, we see it here, but we should also see it now in Visual Analytics. We see that the basic game is here. We also ran the scenario now for jail equals yes. So this means we should now get 2 elements already here. And it takes some time to refresh. Now it's here. We see we have 2 scenarios on the left, the basic game, and the second consider jail. And we see if we just jump between these 2 scenarios, our histogram below is changing and is updating as we do. So that's a very nice and very good way to show what the results are doing here. And I would like to show you now how can you create such a Visual Analytics report. What did I do here to parameterize this report? So what I did was actually quite simple. I just took Visual Analytics, loaded the data that I created earlier, and if I go now to edit mode, you see on the left I have a list which contains the scenario name. This list is just there for selections. I have a slider where I can limit the number of rounds, the first 16 rounds, first 10 rounds if I want, so I can play around with that. Below I have a histogram. I added a histogram object where I said the measure that should be shown is field and the visit frequency. For the histogram, my best practice is I specify the number of intervals to 40 because I have 40 fields, making sure that I get a bar for each field. And I have a cross tab on the right side which shows me the exact percentages. So these are different objects which I just pushed into my Visual Analytics page. And then very important, I went to the actions page where I said, do automatic actions on all objects. This means if I now select scenario number 2, it filters on scenario number 2, consider jail, and it only shows the data for that. So this is a very, very easy and very comfortable way, like what we did earlier. We just added it to our Visual Analytics report by, we had the SAS code, who did the nice calculations. We appended these results to our repository. This repository is already in a CAS table in my CAS user library, and I can use it in very flexible ways in Visual Analytics. This is a way how I, for many customer projects, and not only for the Monopoly board game, use this and run this in different ways. Let's go one step further and refine our rules a little bit to show you how easy it is to do this. So for example, with the go to jail directive, there's also the rule in many Monopoly board game versions that if you roll the duplet not only once, not only twice, but as soon as you roll it 3 times in a consecutive way, you are also sent to jail. So let's now take a look how you can create a third scenario here. So our third scenario is called consider jail and duplet. I again specify a macro parameter for it because I would like to have my programs very flexible. And in the code, you can see I'm now asking if I consider the duplet to jail. You see the code that we had earlier. We say if we consider this and if it happens the third time, your token is not moved forward, but you are sent to jail. So that the player position is sent to 31, and our counter, like we had it before, you are in jail, you have to wait for 3 rounds, and the same is running again. So very simple rule, just add it again. Now I run my SAS code again, I get my results shown here in the output window, and I also get my results appended to Visual Analytics. So if we wait, I think I have a 10-second refresh time here in my VA report, that it automatically updates when I get a new scenario. So you see, scenario number 3 is here, and I can now use it to show it. So we see 2 and 3, scenario 2 and scenario 3 both consider jail. However, scenario 3 also sends you to jail when you have a duplet. And you see this in the results that the bar on field 11 is higher, which mirrors the effect that you also send to jail after 3 duplets, which is very important, which allows you to study what's the effect if I also consider that one. If we now translate this to business language, this would mean it gives us some insight what happens if we consider an additional rule in our framework, in our customer interactions, in our transport network. So you just change rules, change outputs, you visualize them in Visual Analytics and get very good insight. So this is something which you can see very nicely. Let's now jump one step forward and take a look what happens if we not only take a look at the jail directive, but also at the chance cards or the community chess cards. What does this mean? In Monopoly, you sometimes pick cards where it says, now you jump to field number 12, or you go to field number 1, or push 4 fields forward, or jump to the next railroad or to the next utility. Similar task like we had before, we need to add this into our code. And again, with SAS functions and with SAS statements, this is very easy to achieve. And let's take a look how we do this. First, we need to consider we have a stack of cards. So usually we shuffle them before we start playing. And you see here, I start here with a random number where I say, what is the actual community chess card? Which card goes on top? What's the actual chance card? So I draw a random number to get the appropriate card on top in order to have a fresh random order. And then we say, okay, what happens next? We say, if we consider this, and if the player lands, for example, on field 8, 23 or 37, this is where the chance cards are located. And if we said our simulation should consider this with the %if statements, we can now say what should happen if we do that. So if we are there, we need to pick the next chance card. So we have here a select statement, select the actual chance ID, what is the actual card on top, and then it says, if the card is, for example, number 2, if it's the second card of the chance card, it sends you to Illinois Avenue, which is on field number 25, or it sends you to St. Charles Place, or it sends you to the nearest utility. So depending on where you're currently standing, on which of the chance card fields, what is the nearest utility? So you jump forward there and it brings you there. And the same is true for the railroads, and the same is true for the field go back free spaces. So depending on which card we pick, which I have here in my select and when statement, I have instructions. Now I'm getting relocated to different places depending on what are the roots of the card. So again, the fact that we have very high flexibility in a SAS data step to program this, we can do this. And after we have done this, we add the ID of, we increment the ID of the actual chance card in order, you have used this card, move it on the bottom, and the next card is there for the next player. So let's take a look how this looks like. We see scenario number 4 is already here, and when we click on this, we see much more variability. We see we have low visit frequencies on certain fields, which are the chance card fields, because every time you pick something up from there, in most cases you get relocated. And we see that some fields, for example, field number 12, field number 25, you are relocated there quite often because it's Illinois Avenue or other streets where you see the probability to land there is increasing, and for other fields the probability to land there is decreasing. So we see that these rules bring quite a lot of difference into the game, which theoretically you could also calculate this in a mathematical approach with stationary probabilities. However, it's much more flexible and it's much easier to consider scenarios if you program this in a digital twin, which gives you a lot of insight what are the fields with high visit frequency, what are the fields with low visit frequency, because this can also influence your buying decisions. Maybe you better buy fields with a high visit frequency compared to those with a low visit frequency, because if you have bought it in Monopoly, you hope that someone else is jumping on this field. And again, not only relevant for the Monopoly board game, also relevant for many business questions where someone wants to decide, okay, what happens if I open a certain additional route, if I open in a supermarket an additional checkout, what are the results? This can also be simulated very nicely in SAS. Now we have answered our first question. Our first question was, we wanted to see what is the visit frequency of the fields. Let's now jump into a little bit more detail and create a more complicated digital twin, and also try to answer what is the balance, what is the profitability of different fields. And I would like to show you that now by keeping in mind that you can now go and have very complicated rules for this and scenarios. So for example, we could say someone is only buying if he has a certain amount of money on his account. I made my life quite simple here. I said, just in order to simulate this first, the player is always buying if he has the chance to buy, and he's also having the chance to make debt. So to have a negative balance because he's borrowing money from the bank. You can increase these rules and make this a little bit nicer, but for my simulation, I said I start with that one. So let's take a look what this means and how this looks like. In order to be able to do this, if we want to talk about money, we need to get now the price and the rent for the different fields into our system. So you see, I have a data step here, which shows what is the rent if you have just a property or with one house, several houses or more, and also what does it cost for me to buy it or to buy a house. So this is my table. Here, this table contains relevant information which I need for my digital twin for the Monopoly board game. So it's like a lookup table saying if Gerard ends up on Illinois Street and he wants to buy it, how much does it cost? One very nice way in SAS to get this information into a simulation is to create a format, or more precisely an in format here, where I say I create an in format which says the cost 0, meaning cost with no houses, which I get from this table. So I use proc format to create a format which says, if I know the field number, it outputs the cost with no houses, if you buy that. So that's a very powerful way. Get the data, push it into individual formats, which you can then use very flexible in the code. And using this very flexible in the code is a nice way which you can combine with the arrays that we had earlier. With the arrays, I can say, for example, the player position of player 2 would be player pos bracket 2, which gives you the position of player number 2. Player expense of player gives you what's the expense, how much did the player spend, who is currently the value in player. So when I run over the loop, I can do this very flexible. And you can also nest these conditions. We could say, what is the field revenue of the position where some player is currently sitting? So you can nest this to build very powerful calculations and avoid lots of if statements or merges if you use the arrays properly and nest them here in SAS. I have done so, and I would like to show you how this looks like in one very nice code example. And when we take a look for that, we see I now have a macro variable which says, yes, we also consider the calculation of the profit. Things that stay this, and as you saw earlier, I have now a large number of additional arrays. I have arrays for the player balance, for the setup of the fields. Is there a house? Is there not is there no house? What's the balance of the field? What's the cost? Now the rest of our program stays the same. I relocate the token based on the chance card, on chance, and so on. But then we go and say, if we calculate the profit, we need to check. And checking means if the player now lands on a certain field, I have here an array which says the field where the player is currently sitting. If it is 0, 0 means it belongs to nobody, I can buy it. And buying it means the field indicator is set to my number, to my player number. So it means I possess it. The system now knows field 3 is possessed by Gerhard. The cost for this field is increased, and now I use the input function because I get now from the external table we had, I get the cost for this field inside. And also the expense that I have, I increase my actual expense with the cost for this field. This is if it's not owned by someone. If it's already owned by someone who is not me, by someone else, I need to pay. So if it's owned by a different player, the actual player is not the same player on the field, then I need to ask, what is the setup of the field? Do I have 1 house, 2 house, 3 house, no house? And then I again query a different format where I have, because I have different ranks for a smaller or for a larger number of the house. So this is the way how you can do a lot of bookkeeping and calculating in a SAS data step, which allows you to do this in a very powerful way. And you also see this here, how this looks like if you would do this, for example, for other properties and so on. So we have seen now the code, how you can calculate this. This means the table that we generate is now much bigger. We not only have the player positions in 5 variables, we have a large number of variables now, which says what is the balance, what is the wallet of the certain player, how much money do I have, how much fields do I have for each field, is it owned by someone, how much houses do I have on it, what is the balance on the field. So our table has become very, very wide. But wide means also we have a lot of information inside, which allows us to create even more powerful results. And more powerful results means we will go and take a look, what is the balance per field after 20 rounds, after 80 rounds, how does this differ? And again, I would like to show you how you can visualize this in SAS Visual Analytics. So what I built here is again a dashboard where I used a slider for the rounds. This is what you see here on top. I have this is my slider where I can slide over the rounds. I have a box plot for the balance at a certain number of rounds, and I have a line chart over the rounds. So what we see here, for example, if we move our round indicator to 1 when we start, for example, after 20 rounds, we see that we are with many of our properties on average in the negative area, which is quite clear. The game just started, we bought it, we have spent money, but we didn't get a lot of money back. The longer we play, the higher the chances that other people are visiting our properties, meaning that we see higher values and higher incomes of that with certain fields. So you see, for example, if we run over 70 rounds, the longer we play, the more money we can make. And we also see it's not the same for all properties. For some of them, over time, the lines are really picking up, mostly for those where we also have a high visit frequency, because the chance that someone is jumping on our field is quite high there. So what do we learn from that? We learn from that programming our digital twin in the way we just did requires some programming, but we also have the chance to answer now additional questions. So give me a second to stop my video here. Anyhow, it looks like it's running again, but we will be able to jump over that. Let's come to the last question. Why do my children win more often than I do? And I would like to answer this, go and answer this together with you by putting some thought on that. It looks like I am not managing. Now I managed to do it. Okay, so let's come to our last question. Before we take a look at that, let's maybe think. It's very often that it doesn't matter who starts playing. However, with Monopoly, it makes a lot of difference who starts playing, because if you're player number one and you start, you're most likely to be the first one to run around and have more chances to buy properties compared to the fifth player who runs after all the others, and it usually might be a little bit behind and finds many properties bought, so the number he can buy is smaller, and he has to pay rent to others more often. So it makes a difference being the first one, the second one, or the fifth one, which you also see here in this chart on the right, the line chart. The blue one is player number one, and his average ranking being first, second, third, or fifth. At the beginning, it's not good because he has the chance to buy so often, so he spends more money. But over time, so something after round number 5, you see it's changing. His average rank is going down. He's more often the first one or the second one compared to the green line that we have with a player number 5. At the beginning, he has a good rank because he has more money. He didn't have a chance to spend it. He can also only spend it over time. And later on, he has to spend it quite often by giving money to the other players. So in many Monopoly game instructions and in many family, it's played like that. The youngest player is going to start. At least this is the way how I see it in many instructions and many families here when I discuss this in Europe, meaning that you give advantage to the player who starts. And this is also why we see differences and why it is sometimes that younger players, because they're allowed to start, have a better chance to win. And you also see this here on this chart. You see on the left segment here, you see the blue one. So the blue means being number one. And you see that player number one has over time an increasing proportion of ranks number one. So he has the best wallet, he has the most money, compared to player number 5, who over time it's decreasing, and he's very often on the 5th position. So it's not completely equally distributed, but it's an advantage being first, it's a disadvantage of being 5th. This is also something you can get out of the Monopoly digital twin by programming it that way and by getting the analysis and the data out. Let's go and summarize and share some links with you. We answered 3 questions, which is, of course, not the most tremendous business question of a company, but they are good examples what can be answered with a digital twin in a complex system. So I think there is a lot of ideas around how you can translate these questions into business questions for your company or for organization to study processes and more. The Monopoly board game is a good illustration for many analogies with business life. So decisions need to be made. There is information not only interested about the average value, but you would like also to understand what's the variability. Is the variability very high? Is it quite narrow? How much risk do we have? And also strategies and decisions can change over time. And you can also test different player strategies. So for example, one player is playing quite risky. He always tries to buy something, being at risk of not having enough money. Someone is quite cautious. He's only buying railroads and utilities because they're cheap. So you can also try out different scenarios and find out how often does this person win. SAS is a very powerful tool to do this. So you have seen data step, many elements of a data step like formats, arrays, which is incredibly powerful to do this. We also have analytic procedures, IML, to do more complex and more elaborated mathematical stuff. And as you have seen, SAS Visual Analytics is your best friend when it comes to visualize these results. I've shown here a few selected links for simulations. There is an excellent paper of Rick Wicklin, 10 tips for simulating data with SAS, where you can find a lot of ideas for that. There are also books from Rick. There is also my Applying Data Science book, where chapters 26 and until 28 completely deal with the Monopoly board game. There is also a webinar series where I have shown similar cases already a couple of years ago. And I'm also publishing a lot on LinkedIn. And as I mentioned earlier, you can follow my webinars on YouTube, which I have here. And there's a very good article which allows you to bring all these to get. This is my SAS Communities header article. So it's the data science and data preparation article overview by Gerhard, which lists all the articles that I have. And stay tuned for that, because in the next, let's say in the next week, I will start pushing there the articles which you have seen today, different ideas how you can do this and how you can provide that one. And having said that, I'm finished with what I wanted to tell you, and I'm happy to take your questions and any feedback. Thank you very much.
Yes, thank you. With that, we will be moving into the Q&A segment of the webinar. All right, now on to our first question here. Does this only work for the Monopoly board game, or would it also work for complex business environments?
The answer is yes, it also works for complex business scenarios, because that's also the nice thing that what we do in many custom implementation projects, we also use this for if then else scenarios. For example, what does it mean to make different decisions with a risk portfolio in banking, or with different decisions in a transportation network? So what you can do here is a very wide range. I'm using the Monopoly board game because I think it's a very good illustration to show what can be done here and can be used here.
Perfect, thank you. Another question here is, what is the runtime of such a simulation with 10,000 iterations?
The runtime that you have seen in my demos was with 1,000 iterations. So you saw that this was running within 1 or 2 seconds, the data step. What might get a little bit tricky if you increase the number of iterations and games, if you then start study in detail the balance and the profitability of the fields, because then you are going to transpose a large number of columns. So the simulation itself will still run in seconds, but you might want to put some thoughts then into the data preparation piece, how to arrange the data nicely, which can be maybe more than 10 seconds, but still very nicely doable.
Okay, thank you. Someone's asking, do I need special programming skills to implement a digital twin like this?
I strongly believe if you're a SAS programmer who is comfortable using a SAS data step with formats and arrays and maybe some macro languages, you're good. So if you have SAS programming skills, working with SAS, I think you're good to go and build your first your first digital twin.
Perfect, thank you. Someone's asking, can you also do statistics on the significance of the differences between the yields of the fields, for example, in the error bars in the plot?
The answer is yes. You can do this. For example, you can do this in Visual Analytics by running this. However, so I would like to differentiate what's possible from a technical perspective. So technical is possible. I would be careful with over-interpreting the statistical results because we are here in a simulation scenario. So for example, if you're after p-values or something like that, if you just increase the number of simulations, you would probably get something very quickly significant. But just calculating error bars like standard deviations, that's definitely a fair way to take a look at it. And yes, this is possible in both SAS procedures and in Visual Analytics.
Makes sense. Thank you. Someone just asked, what makes this example different from, say, a simulation model?
I would say it is a simulation model what we have. So when I first published this already 18 years ago, I just called it, this is my Monte Carlo simulation for the Monopoly board game. Seeing on many conferences, many organizations discussing what is a digital twin, it is also a digital twin what we are doing here, because it allows you to mirror a real world situation in a digital way, which you can use to understand deeper this and take a look at this. So if someone feels more comfortable to say, this is my simulation model, I'm fine with it. It is, however, also a digital twin because it mirrors in a digital way the Monopoly board game and allows you to experiment with that. That's why it's a digital twin.
Got it. Makes sense. Save the most important question of all here for last, possibly. Which color of properties should I buy in Monopoly?
It's the question whether you just focus on which color properties over this. I'm a big fan of looking at the outcome, at the results that I showed you. What's the high visit probability and what's the high average balance of this? Because this might not be just one color group. This might be individual fields. So it might be good maybe to buy all of them of one color group, but it might also be a good advice to pick maybe field number 12, 25, 37 and get a better mix. But as soon as you have run this, and when I share the results, you can run this on your own very easily. You can also then aggregate the results by color groups and get aggregated values for that and have a good view on that. Also, what I would like to emphasize here is it's not only the average balance, because it might be for someone, yes, the average balance is higher for this field, but also the variability is very high. So it's very risky to buy this. Maybe go for a slightly lower balance and lower variability, lower risk with that.
Perfect. I usually go for dark blue.
Thank you.
I usually go for dark blue. Just make it easy. Just stick with that one. I'm afraid that's all the time we have for questions today. If we did not get to yours, we will answer all unanswered questions in our follow-up communities post. Thank you, Gerhard, for your answers, and thanks to all of you for joining us. On behalf of myself, Gerhard, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.
Thank you. Cheers.